Howdy, AP PreCal. It's Ms. Kosh. This is a summary of what we were looking at with the arithmetic and geometric. So I wanted to talk through this a little bit. An arithmetic sequence, their terms have a common difference, and it's related to a linear function. They increase the same amount each time. So the version of the formula that I actually like is A sub n is equal to a sub 1 plus n minus 1 times d. Or you could say that if I have the kth term, then I need to add the common difference n minus k times. A sub 0, this is once you've, this is the 0 term. D is your common difference. A sub k is some random kth term, whatever that may be. This is my favorite version. This is how I've been teaching it for probably longer than you've been alive, but anyway, here we go. Okay, so here's an example. If I have a sub n is equal to 3n plus 1, my first term, a sub 1, would be equal to 3 plus 1 is 4. My second term would be equal to 7. My third term would be equal to, plug in 3, that's 9 plus 1 is 10. And so notice what I can do here is I can say I have 1, 4 is here, 2, 7 is here-ish, 3, 10 is here-ish, something like that. Notice I'm not going to sketch out the entire line because it's a sequence. It doesn't have, it's not continuous between these points. But these points fall on a line whose slope is 3. And at the 0 term would be here. So your y-intercept is actually not a term of your sequence because you start with the first term, the second term, the third term, and so forth. Okay, summarizing this, a geometric sequence has a common ratio. We're multiplying by the same amount. And if you think, oh no, I'm not multiplying, I'm dividing, well, you're multiplying by that fraction. Like instead of dividing by 2, you're multiplying by 1/2. My favorite version of this formula is actually not written here. My favorite version is g sub n is equal to g sub 1 times r to the n minus 1. So if I'm at the first term and I want to get to the nth term, I have to multiply it by the common ratio n minus 1 times. The g sub 0 is your 0 term, so it's kind of like your y-intercept that isn't all that helpful. No, is that right? Yeah, okay. R is the common ratio, g sub k is some kth term. What do they tell us here? They behave like exponential functions except they're not continuous. So we would have individual points just like we did here, but they would follow the shape of an exponential function. Increasing geometric sequences increase by a larger amount each time. Percent increase always stays the same. Okay, so we'd have a growth or decay factor. On this one, so if I have g sub 1, when I plug in 1, I'm taking half of 8 and I get 4. So my very first term is 4. G sub 2, when I plug in a 2, I get 1/2 squared, which is 1/4. So a fourth of 8 is 2. Okay, or I'm multiplying by 1/2, so g sub 3 is equal to 1. G sub 4 is now equal to 1/2, and they get small rather quickly. So g sub 1 is 4. G sub 2 is 2. G sub 3 is 1. G sub 4 is 1/2. And so this would start to follow a pattern that goes something like this. But notice I didn't make it continuous, and actually these numbers aren't necessarily the best to help us see what's happening. But that's okay. All right, I hope that was enjoyable, and I think I will make a challenge video.